Hey students, we're still understanding decimals. Let's take a look at the math practices we'll be using. You might be surprised to learn that we are using all of the math practices. We will be persevering in solving problems, thinking about what makes sense, talking, explaining, showing our thinking, using the right tools, checking our work, looking for patterns and connections throughout this lesson. Let's take a look at our scale. In your Go Math book, this is lessons 3.8 and 3.9. It's pretty easy, so I bet you're excited about adding and subtracting decimals. You're going to find that it's very similar to what you've done before. But our goal is to evaluate expressions that have decimals in them. And we're specifically looking for addition and subtraction in the expression. So let's get started. We can use base 10 blocks when we are adding and subtracting decimals, and you're going to find that decimals like to dance together. What exactly does that mean? Okay, when we're adding and subtracting decimals, let's talk about adding first. Maybe we have 3.42 plus 5.67. We can use base 10 blocks to do that. Let's say that a flat no longer represents 100, but it represents 1, that a long no longer represents 10, but it represents a tenth, and let's say that a cube no longer represents 1, but it represents 1/100, or 100th. That sounds odd. 100th. So let's make the number 3 42 hundredths. If this shape, which is a square, represents 1, then I will need 3 ones. I will also need 4 tenths and 2 hundredths. Now for the other number, I will need 5, 6 tenths, and 7 hundredths. Now I need to group these so I can add them together. Here's 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This now turns into a flat. 1, 2, 3, 4, 5, 6, 7, 8, 9. And these will stay as 9. So what do we end up with? Oh, not 8. Let's see. What do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 and 9 hundredths. So we have 9 and 9 hundredths. And what you saw take place right here is regrouping. You'll get to see that a little bit better on the other side. I'm going to pause the video and solve using the standard algorithm. Okay, boys and girls, as you can see, I've used the standard algorithm. This probably looks very familiar. It looks just like 3-digit addition, 4-digit addition that you, well, 3-digit addition that you were doing in what, 2nd, 3rd, and 4th grade? You're exactly right. The only thing you have to remember is that the decimal needs to be in the same place throughout your equation. That's what I mean by, baby, decimals like to dance together. They need to stay together. And you'll notice that we use the same algorithm that you've been using throughout elementary school. We've got regrouping taking place here because 6 and 4 makes 10. So we put 0 to represent the ones place and we regroup the 10. That's what you saw happen over here as well. You're probably thinking, oh my goodness, decimals are so easy. I'm glad you think so because it's exactly true. Now we're going to move on to subtraction. It's the exact same concept. What if we had 5 and 67 hundredths minus, let's say, 2 and 59 hundredths? We would use the same strategy. Notice that the larger number, of course, is first. Because this is pretty simple, I'm going to solve it and come right back. If you'd like to, you can pause the video and attempt to solve the problem on your own. Okay, boys and girls, maybe this is what you came up with, but let's just talk through it in case you weren't sure. Notice that in black, I drew, or I represented with base 10 blocks in the form of a quick picture. This is called a quick picture. I represented the number 5 and 67 hundredths using a quick picture. So you'll notice here that I have 1, 2, 3, 4, 5, and then here I have 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6, right? Then in red, because I knew I couldn't subtract 9, I had to regroup. So I regrouped here. I regrouped this 10 into 10 red hundredths. And then I was able to subtract 1, 2, 3, 4, 5, 6, 7, 8, 9. I was able to subtract 9. And then how many do I have left? 1, 2, 3, 4, 5, 6, 7, 8. Here's the 8. And then how many tenths did I have left? I had 5 left, and that's what I was subtracting, 5. So then there were 0, and then I had to subtract the ones, and I have now 1, 2, 3 ones left. I hope that makes sense. If not, you can see it in the standard algorithm. This regrouping that we did right here is represented in this picture. And that's how we end up with the same answer. I hope that makes sense. Pretty neat, right? Let's try a problem. Mackenzie and Caitlin, hi girls, decided to compare the lengths of their pets. Mackenzie's pet is 35 and 45 hundredths centimeters. Oh my goodness. We really would likely say 35.45 centimeters, and Caitlin's pet is 67.22 centimeters. How much longer, wow, that's important, is Caitlin's pet than Mackenzie's? Let's circle our important numbers, and we've underlined the question. We want to know, what's the action word? How much longer Caitlin's is than Mackenzie's. So Caitlin's is the longer one, and Mackenzie has the shorter one. So that's actually how we're going to organize our equation. Now, at the beginning of this, it's only going to be an expression. Notice that I am not using base 10 blocks. What's the reason why? Well, our numbers are really large, and I don't see myself drawing 67 boxes on the page. That is why we use the standard algorithm, because to draw 67 boxes and then subtract 35, that would work. However, it's not the best way to solve the problem. That's what we mean when we say we will use strategies and choose the right tools. That's right here. We'll use strategies and use the right tools to solve a problem. The best tool to solve this problem right now would be the standard algorithm. So let's do that right now. As you can see, I'm going to have to regroup already. 12 minus 5 is 7. Can I subtract 4 from 1? No, so I'm going to regroup again. 11 minus 4 is 7. 6 minus 5 is 1, and 6 minus 3 is 3. Does that make sense? Now we need to answer the question. Well, actually, we've evaluated and we solved. Now we need to check our answer. If our answer is correct, then 35.45 plus 31.77, or 31 77/100ths, we need to be able to say it both ways, students, should equal 67 22/100ths. Let's find out. 5 and 7 is 12. 7 and 5 is 13. No, 7 and 5 is 12. I just did that. Seriously, Miss Addison? Okay. Yay! 67 and 22/100. Maybe when you're solving problems, you talk to yourself in your head like I do. All right, here's the we do. I want you to pause the video and try it yourself, and then we'll come back and see. Yes, I know we're supposed to do it together, but I have a feeling this is so easy for you, you can do it on your own. Pause the video, no peeking. Okay, let's take a look at this problem. Now, we know that Luke has 3 bags, so we added 28.3, or 28 and 3/10. We added that 3 times. We got 84.9, and then we subtracted 21 because of here. We subtracted 21 from that because he gave it to Brandon. So he will have 63 and 9/10 left. Now, look at how the answer was written. Luke will have 63.9 grams left because 84.9 minus 21.0 equals 63.9. Now, a better answer, boys and girls, would have been to say this. 28.3, or 28 and 3/10 times 3 in parentheses, and then minus 21.0 equals 63.9. Please don't forget that one of our biggest focuses in 5th grade is being able to use PEMDAS and write expressions like the one below. This is actually the best way to express the problem that we solved. Now on to the you do. I want you to solve these two, oh boy, and come back. I'll be back with the answers. Pause the video now. Okay, boys and girls, here are the problems solved using base 10 blocks and the standard algorithm. Please remember that in this problem, or in these problems, that a flat equaled 1, a long, instead of equaling 10, it equaled a 10th, and a cube, instead of equaling 1, this time it was 1/100th. And we just put the zeros there. We can put the zeros on either side. You probably noticed that and you're wondering, why do you do that? Because it's a good placeholder when you're trying to make sure that your decimals are dancing. Okay, check your scale. Let us know how you're doing. We're happy to help you. And if this video was helpful, which strategy do you like better? Base 10 blocks or the standard algorithm? You can leave a comment below. Until next time.